We'll start with the first module of EC305 microprocessor and microcontroller. In this module we will be seeing the microprocessor, the basic operation of a microprocessor, and we will see a microprocessor based system. So as an introduction, we will see what is a microprocessor, how you can define a microprocessor, and in the later part of this module we will focus more on 8085 microprocessor and its architecture. So in the first part we will see what is a microprocessor and how do a microprocessor work and a microprocessor based system. So this is your textbook that you will have to concentrate. 8085 microprocessors, architecture, application and programming. So what is a microprocessor? In general, you can say it is a multi-purpose, a programmable, integrated, a clock-driven, a register-based system. So you are using a laptop, you are using a mobile phone, all the devices are controlled by a microprocessor. So you can say that the microprocessor is a programmable integrated device. So you can program it. It is an integrated device and it is being used for it can perform the computing and it can do the decision making. So it is something like a central processing unit, CPU of a computer. So what is the operation of a MPU? MPU is the microprocessor as a CPU. You can call it as a microprocessor unit. So what is the operation of a MPU, a microprocessor unit? So you can say that the MPU or the microprocessor unit, it reads the binary instructions from the memory. Okay, so the instructions are being stored in the memory. It is being stored in the form of binary information. So when you consider a program, you can say that you can either write or store the program in high level language or assembly language. Okay, so this assembly language program which is called as mnemonics, it will be converted to the machine language, in which you will be having a stream of binary bits. Okay, so the microprocessor basically reads the binary instruction from the memory. It accepts the binary data as input. So when the instructions are read, you are going to decode the instruction. After decoding the instruction, you are going to process the data according to those instructions, and it provides the result as output to any of the output devices, or the results will be stored in the memory. How do the programs run on a MPU? We have seen the basics of the program execution in the computer organization in your previous semester. So this is how it works. Normally you are going to have the fetch, decode and execution of instructions stored inside a memory. So the first process is that you are going to fetch the instruction. After that, the fetched instruction will be decoded, and based on that you identify what is the purpose of the instruction and you are going to execute the instruction. So you can say it as you're going to read, interpret and perform. So when you are going to fetch the instruction, you need to have a bus. So in general you will call it as a system bus. In the coming sessions we will see more about the system bus. So using the system bus, you are going to fetch the instruction. You are going to fetch the instruction and data from the memory, and you are having the registers inside your microprocessor which can be used to store the data temporarily. So based on the instruction, after you fetch the instruction, you decode it, you find out what is the required operation, and the operation will be performed by the ALU. So the ALU performs the computations. It might be addition, subtraction, and or whatever it might be. The ALU perform the computation, and after the computations are being performed, it sends out the result to the output using system bus. Now we will see the basics of how a microprocessor based system is being organized. Now we will see a very simplified structure. So in this structure, it is a very simplified structure. You can see that you are having the MPU, a microprocessor unit, in which you are having the ALU, registers, control unit, and the system bus, which is being used to communicate. The processor communicates with the output devices and the input devices and the memory using the system bus. So this is a very simplified structure. So you are having the ALU. So this ALU is being used to perform different operations. You are having a set of registers. We'll concentrate more on the registers in the coming sessions. Now these registers are basically used to store the data temporarily, and you are having the timing and control unit, which provides the necessary timing and control signals for the operation. Okay, so the processor communicates with the different input output devices and the memory using the system bus. So the timing of the communication process is controlled by a group of circuits, and the circuit is known as the control unit. Okay, and you can see in the memory, in which you are basically having two parts. One is your ROM, read-only memory, and the second one is your read-write memory, which is basically known as RAM. Okay. Now this ROM is used to store the program that do not need any alteration. So the program stored in the ROM can only be read, they cannot be altered. Something like, you can say, take an example, something like a monitor program. This monitor program is a program that is responsible for providing the necessary instructions to the processor to monitor the system. So generally you can say that ROM, the program stored in the ROM can only be read, you cannot alter the program. And coming to the other kind of memory is the read-write memory, which is basically known as RAM. So this memory is known as the user memory. It is used to store the user programs and data. So the read-write memory or the RAM memory can be easily read as well as altered. Okay, and you can see the different input-output devices which is being connected to the microprocessor using the system bus. So we will see the explanation of the simplified structure, which you have seen in the last slide. You are having the arithmetic and logic unit. So the ALU performs the various computing functions on the data. It performs the arithmetic operations like addition, subtraction, the logical operations like AND or XOR, etc. You are having a register array. The microprocessor consists of various registers under different name. It has been temporarily used to store the data during the execution of the program, and this data can be accessed by the user through the instruction. You are having the control unit. So the control unit provides the necessary timing and control signals for the operations inside the microcomputer. Now you can summarize the microprocessor based system. It consists of a CPU, a central processing unit. It includes the ALU, the registers, the instruction decoder, and the control unit. So the purpose of the instruction decoder is that when you are going to fetch an instruction, the instruction will be brought to the instruction register, and from the instruction register, using the instruction decoder, you will decode the instruction and identify what is the instruction, what is the purpose of the instruction, and the ALU will perform the required operation. Okay, and we have seen what is an ALU, we have seen what is a control unit, and we have seen the memory. So it is being used to store the instruction as well as data. You have seen two kinds of memory, the RAM and ROM. RAM is basically a read-write memory. We have seen the we'll then coming to the input devices. Okay, and so a device that transfers the information from the outside world to the computer, and the output devices, so the device that transfer the information from the computer to the outside device. So this is a very basic structure, and in the coming sessions we will concentrate more on the terms mentioned over here. Now we will see an example of a microprocessor based system. So we will take a microprocessor controlled temperature system. So you have been given with a task to make a temperature control system. So consider a room, and inside the room, if the temperature goes below a particular value, you need to turn on the heater, or if the temperature goes above a particular value, you need to switch on the fan. Okay, so you are having an MPU, an 8085 MPU, and you are having an input device which is a temperature sensor. So this temperature sensor is being connected to an input port, which is basically a latch. So the temperature sensor is being connected to an input port using an ADC. We'll see what is an ADC, and you can see you are having three output devices which is being connected through three output ports. So the output ports are basically the latches which is being used to connect a device with the MPU. So the output devices used over here is the fan, heater, and an LCD for displaying the temperature. And you are having the memory, the ROM, as well as read-write memory, which is also known as RAM. And these connections are done through the system bus. Okay, now the explanation. You are having the temperature sensor, a sensor which converts the temperature into an electrical signal. Now the signal that has been obtained from the sensor is basically an analog signal, and you are going to convert the analog signal into a digital value. It might be converted to an 8-bit value or 16-bit value based on your requirement. So this ADC convert the analog value to the digital value. Now take an example, consider it as an 8-bit value, digital value. So through the input port, the microprocessor reads the temperature value. So the microprocessor reads the temperature value, and based on the value, if this temperature value is above a particular temperature, the threshold temperature, you are supposed to switch on the fan. So the microprocessor gives the corresponding signal to the fan using the system bus, using the output port, so the fan will be switched on. Now take the second case. If the temperature is below a particular value, if the red temperature is below a particular value, you are supposed to switch on the heater. So the microprocessor, based on the calculation, will switch on the heater. Okay, in both the cases, whatever might be the temperature has to be displayed in the LCD screen. So the microprocessor will provide the necessary information to the LCD screen through system bus, through the output port, and the value will be displayed in the LCD, and the program will be stored in the memory. The user program will be stored in a read-write memory. So this is an example for a microprocessor based system. Thank you.